Welcome back to Module 15. Now, if Module 14 represented a little fork in the road to briefly touch on some command line tools to help us automate things in the modeler and in the hub, now we're rejoining the highway. We're rejoining the main thrust of this course to talk about a very important subject. It's something we briefly touched upon in the previous sessions. We talked about how entities in your model can have lots of attributes and how you can create values for those attributes. One of the things that comes up quite often when we're talking to freshly new starting customers is the concept of inferring instances of entities. What does it actually mean? What is it good for? And why do I care? Part of the problem, I think, is the vocabulary. It's not often that you'll hear me saying, yes, I'm going to go and I can infer that my colleague Steve has a pet because he has a very large vet bill. Essentially, I'm deducing that because he has a vet bill, he must have a pet, but I wouldn't use the word infer. Let's talk about inference and inferring entity instances and what that means and why it's useful. So, what do we mean when we say I'm going to infer an instance? What does it mean? Is it painful? How do we do it? How can I do it from a mechanics point of view? What functions are available to me? I should really say, what two functions let me do this? If I can do it, what else? What next? Basically, I want to make it as simple as possible to understand what it means when we say we're going to infer some entity instances. And we'll look at the idea of using them in an interview. So, starting at the top, what do we mean by inferring an instance? Well, you've already become familiar with the idea that in Intelligent Advisor rule models, you have attributes such as the customer name, and that attribute can have a value. Richard, Bob, Anna, Steve, whatever. And you've become familiar with writing rules to set the value of an attribute. You know, the cost of the fish and chips equals the cost of the fish plus the cost of the chips plus the service charge. You've assigned a value to the cost of the fish and chips. Very simple stuff. Sometimes in more evolved models, you need to not just give values to variables, give values to attributes. You want to infer that data exists that didn't exist before. Let me give you an example. You walk into a shop and you make a purchase. You purchase a pair of sneakers. And the value of those sneakers is $110. And that shop has a business rule that any customer who spends more than $100 in a single transaction gets a free t-shirt. So this free t-shirt that you didn't have, you didn't ask for, has manifested itself as part of your transaction. The existence of an order of greater than $100, in my business logic, infers the existence of this t-shirt, and you get a t-shirt to take away. So you haven't just inferred the existence of a discount, or you've inferred that you're a gold customer. We've actually inferred an entire instance of an entity. So this means that in my model, I would have the order, and I'd probably have the order lines as well, and I'd have an entity called the free gift, perhaps. And I would never ask my sales assistants to enter manually that there's a free t-shirt. What's the point? Because I can set a rule that says if the order is greater than a certain value, there's a free t-shirt. I want to infer the existence of the t-shirt. Let's see how it's done. And hopefully with a short demo now and a longer demo at the end of the module, this will make a lot more sense. In this one, we're going to start with something really simple. We're actually going to go back to the concept I just mentioned, the idea of having a model that contains the order line, and the free gift. You'll remember from previous chapters that when you create an entity, you always put it in the singular, and when you build the text for your relationships, that's where you express the notion of plural or not, depending on the cardinality, depending on the kind of relationship you have. So in my case, I have order lines for the order, and I have the free gift for the order. So free gift in my case is going to be, let's just say that it's one free gift. I don't want to give people too many free gifts. And I'm going to go to my rules, and I'm going to open up my Word document, see the work that I've done so far, and then I'm going to finish the work in front of you. So far I've done nothing more than say, okay, the total order value is going to be the sum of all of the order lines, and I'm going to look at the value. Fine. And the order line value is the quantity times the price. So obviously if you order 2 pairs of sneakers at $50, that's $100. So I need to calculate the order line and then calculate the order total value. Fair enough. So now I'm going to go to the last part. I'll come down a little bit and I'll zoom in a little bit so we can see what I'm doing. And for this demo, I'm going to use the Rule Assistant because it's my favorite tool. Using the Rule Assistant means I make less mistakes, which, trust me, when you're doing a live demo, it tends to be the case. I'm going to use a special function called Infer instance, which basically means create an instance of something. What do I want to create an instance of? I want to create an instance of the free gift for the order, clearly. And I'm going to say free t-shirt. So that is actually something very important. For now, we'll just say this is going to be the t-shirt, but I'm going to come back to this concept of free t-shirt in just a moment. If, clearly, I don't give you a free t-shirt all the time. And I'll finish off by saying the order total value is greater than 99. Now in this little demo, I haven't qualified whether it's $99, 99 pounds, whatever. My attribute name is order line, order total value. It should be total value in dollars or whatever. I'm cutting corners to make this as simple and as fast to follow as possible. So I've said, give me a free gift if the order value is greater than 99. I'm going to validate my work, make sure there are no issues. And I can go ahead now and debug to see what that actually means. I'm going to use the Data tab for now because it's easier to just focus on data. We haven't designed any kind of graphical user interface at the moment. Right now, there are no orders. So I'm going to go ahead and create an order. And I'm going to say, okay, this is order number 1. There it is. And right now, there are no order lines. I'm going to add a single order line. Before I enter the data relevant to the order line, I want you to notice that the free gift for the order is already there, but it's changed color. The yellow and the italics is telling me that Intelligent Advisor has worked out that the free gift is not something that I can add or delete manually. I don't have control over the existence of the free gift. The free gift is inferred. So it's up to my Word document to decide when a free gift exists. So I'm going to go to the order line and I'm going to say, I ordered 2 sneakers and I'll say that the price was 50. So by my logic, I'm going to reach an order line value of 50 times 2, 100, and watch what happens over here. Keep your eye on the free gift line. Suddenly a plus has appeared and said, yep, you just got yourself a free t-shirt. So it inferred the existence of the free t-shirt because my business rule was met. I'm going to go back and change the price of the sneakers to 48. Watch the free gift. The free gift has just disappeared because I no longer meet the criteria to obtain the free gift. And you're probably thinking, well, that was actually quite underwhelming. But there's a really, really clever concept here. Data that didn't exist can be created by my rule. My rule creates a t-shirt. And you're thinking, okay, so what? Let's think about the business uses for this. Well, because you make an order, I will create an invoice. Because you ask for help involving a incident with a lost dog in the high street, I will create an activity in the diary of the police person, man or woman, who is going to come and look after your problem with the lost dog in the high street. Creating records, if you They're not records, they're instances. But creating instances like this is a prime candidate for when you want to send data back to an external application. Maybe the external application is going to record the fact that this free t-shirt existed and is going to record it in a separate table in a separate database. So by creating these instances, we're coming closer to providing output entities that are specific to our needs. So aside from me getting terribly excited about that, what does this actually mean? It means, first of all, here's a summary of what we did, nothing very complicated. We inferred the existence of the free gift. The free gift in quotes, which you can see right here, I'll just show it up to you with my pen. You'll remember from your previous chapters about entities that when you create an entity, and I'm going to switch back to the application one final time now, when you create an entity in the modeler, like I have here, the free gift, you'll remember that every entity has an identifying attribute. And in my case, I was lazy, I just called it the free gift. So my rule that created the free gift, the text in quotes is actually the identifier of this instance. It's the identifier of this row. It's the identifier of this unique instance. So in real life, I might come up with some sophisticated logic, like I would say, well, actually, the identifier will be the customer ID plus an underscore, a dash, plus XYZ, plus a space and free t-shirt. Which would mean, if I go to my logic again, if I go to my debugger and apply those changes, and I go to global and I'll say the customer ID is, let's say that this is my loyal customer, Steve Pro FX. He's a gold customer. He's gold, no, he's gold. And when I go to my free t-shirt now, and if Steve makes a big order, let's say he uniquely perhaps orders 3 sneakers, and he gets a free gift. Now I have an identifier for my t-shirt that maybe is meaningful to the external application. You can probably see where this is going. The identifier doesn't have to be an identifier that is useful for a human. This could actually be something that's very useful for another application or some other purpose. So as long as you have an identifier, it doesn't really matter what it is in this context, it becomes very useful for handling the concept of dynamically creating identifiers. Now that I've got that far, and I've viewed the outcome in the debugger, what else can I do with this? Well, I can extend the model. There could be the need to take into account further business logic when I'm dealing with my order line. Only certain product types apply. Remember that I had an infer instance with an if. So I could start to add more if. If the product is a sneaker, then it has to be $120. If the product is a t-shirt, don't give him a free t-shirt at all because he's already just bought one. There's all sorts of extra logic I could create. But the key is this: I cannot myself add the t-shirt. It's only through the order and the order lines that I add to my order that I get the t-shirt or I don't. And that's what makes this so powerful. It's creating data through logic. So I'll add another order, and I'm ordering 50 copies of my book. I'm ordering 3 copies of my book, which I think is a good deal, and I get a free t-shirt. So what just really happened in there? We inferred the existence of a t-shirt. We could have just inferred a single attribute. We could have created a Boolean that says, can have free t-shirt, and said it's true or false. But why didn't we do that? Well, because a t-shirt, or any other free gift, it maybe has many attributes. Maybe we give you a free t-shirt, but then what? Well, then we have to ask you, what size do you want? What color do you want? Do you want the logo of your favorite soccer team on it? There's a whole bunch of extra attributes that may apply to this free gift. So maybe the external system is waiting for that to be completed. So we may have many rules that operate on the t-shirt. Once we've created the t-shirt, we can write as many logic rules as we want to infer new attributes, calculate values, whatever. So in this case, you can see I've taken a step further, just like I showed you in my brief demo, and I've made changes to how the unique identifier of the instance is made. I've included the customer's favorite color, the customer's size, and underscore t-shirt. It's up to us to build this. So in that case, that means that there must have been other attributes. Attributes that were used to implement this naming convention. The free gift color, the free gift size, the free gift type. It's up to us to build out into the model that we need. Notice the second point. In an interview, we could even go so far as to ask the user to complete the data about the t-shirt. Once the t-shirt has been brought into existence through inference, we can then ask the user to complete the picture. So I'm going to go one last time back into the application, and I'm going to go to my modeling application, and I'm going to demonstrate simply, very quickly, I can create a screen, and we'll call this free gift specifications, and I will say for the purposes of my demo, I will always display it so I can show it to you easily. And I will add an entity container. An entity container which will show free gift. I will then add anything that I need about the free gift. So I'll add, for example, the free gift name. And I'll take the trouble here now of adding one final attribute, the free gift color. And it will be a text field. And I will add this. The key thing that you've probably noticed is there's no add button. There's no remove button. A container doesn't let you do any of that because we don't have the permission, if you will, to add or create t-shirts. That's governed by our rule. So we'll need simply a container to show the t-shirt. So if I run my debugger, and this is the last time, I'll go into the interview, and you'll see that I now have a page that says the free gift is Steve Pro FX Gold Free T-shirt. What's the color? So I can complete the details of my free T-shirt as I go along. So my T-shirt now is a combination of, let's say that I want it to be red, data that is input by a user and data that is inferred by my Word document. So I can complete the process of asking the user about the t-shirt right here in the interview if I want to. So that was a really simple example. Let's look at another example, a little less artificial. Consider the order again. When you buy something from a large online store, you maybe buy multiple items. You buy 2 items and they're shipped to you as part of your order. Sometimes the online shop will tell you that it's going to send you both items in 2 separate shipments. At least it happened to me the other day. It said, okay, we'll ship you this one first because it's available right now, and then we'll ship you the next one in a couple of weeks. So in a sense, every order line has its own unique shipment. So when I've ordered 2 sneakers and a t-shirt, maybe the sneakers arrive first, so that's shipment number 1, and then you have the t-shirt that arrives later, that's shipment number 2. You can probably guess where this is going. We can create a logic that says, okay, when an order line is ready to be shipped, create a shipment. So if there's 2 order lines, we will infer the existence of 2 shipment lines. So you might see something like this. You'll notice that in this case, in this screenshot, I've actually used the longer version, which is the relationship between the order line and the shipment. The order line ID exists. as opposed to using infer instance, which is the short version that I used earlier on. So how do we translate this? It basically says, okay, I understand there's a relationship between the order line and shipment, and I should create a shipment for every order line ID. So if I have 2 order lines, I should have 2 shipments. And we could then extend that to say, if the order line is complete, or if the order line has a value of greater than whatever. Then the second line says, okay, well, when we create the shipment, we need to know what to ship. So the shipment product, and this is a clever little rule here, it says, go back to the relationship between the shipment and the order line. But I don't know if you can notice, and I hope you have, is you've got a relationship between the order line and shipment. So it's order line to shipment. And here, it's shipment to order line. This is actually the same relationship between shipment and order line, seen in both directions. In one direction, it's useful for creating the shipment, and in the reverse direction, it's useful for knowing which product am I supposed to be shipping. So that's a great use of inverse relationship. The for function assumes that your order line ID is unique, otherwise you'll get an issue. It's beyond the scope of this chapter, but the for function only works with certain cardinalities. So you can take this as far as you need to, and in a moment I'll show you back in the application. There are lots of examples of this in the example project. The second function that you may encounter when you're working with inferring instances of entities is called infer instance for. It's a unique concept in that it creates what they call counterparts. Let's explain. Suppose you have an entity called the existing order, and you want in logic to create a copy of an existing order. So it's a one-to-one. It's a case of take that, duplicate it, copy it, create a counterpart. So for every existing order, there will be a maximum of 1 new order. So that's called infer instance for. For existing order, create a new order. The difference here is that it's very tightly controlled as to 1 exists, 1 can be created, maximum. So infer instance for. There's an excellent worked example in the online help involving students and universities and students wanting to go to particular universities. Clearly, if a student has applied to 3 universities, well, there's really only those 3 that they are ever going to attend, even if there are 50 universities in the country. So we're going to use infer instance for to infer only those universities that the student has applied for. So let's take a look at this. Notice the difference. Here in this natural language version, we have exists for. You may recognize from the previous example, it was just the word exists. So as soon as you see exists for, you know that this is a natural language expression of infer instance for. The student's potential university exists for the enrolling university. Basically, we're creating counterparts, copies. Then we're using the technique we saw before to go and get the name of the university. And then we are going to use the same technique to get the entrance score for each university. So if there are 10 universities, each one of them has an entrance score. I have a particular score that I've scored, which limits the number of universities that I could apply to. So what we're saying is the student would be accepted if their score was greater, so the university score was less than or equal to the student score. So it's a way of ensuring that we only propose to the student universities that potentially would accept them. Anyway, we're going to go back in the demo and see both the infer instance and infer instance for in action. But what do I want you to remember for now? I want you to remember that essentially what we're talking about here is data is being brought into existence by a rule or rules. The t-shirt didn't exist until I told it to be created. This is simple yet incredibly powerful, especially when you are connecting to an external application that is giving you input, let's say an order, but is expecting a shipment as output. How will you create that shipment? The answer is you'll look at the order, you'll infer the existence of a shipment, and the shipment will be the output from your project. It's very powerful. Inferred data can't be mapped in to a project, so the external system cannot send you the shipment if you've decided that it's going to be inferred, because you've said that OPM we will write a rule to infer the existence of the shipment. So it's the model that decides whether the shipment exists or not. So it's outbound rather than inbound. That's coming up in the demo. That's it for now.